GPS positioning is completed in 3D using 4 satellites rather than the 2D example using 3 reference points that we just went through. When trying to determine a position in 3D, imagine using spheres instead of circles or radii to find a common intersection. This is because GPS will also determine your vertical position or elevation on Earth as well. When thinking about the fishing example and applying it to GPS positioning, we would now like to think of each dock as a satellite. However, instead of 3 docks, we will instead have 4 satellites. Now think of each of these satellites as having a sphere around it. Each sphere is a different size, based on how close it is to you and your GPS receiver. But instead of these spheres intersecting at a specific point, the spheres will instead only intersect to an area. This is due to the fact that there are differences between the GPS receiver's clock and the satellite's clocks. These differences cause errors in determining the true distance to each satellite. Therefore, the estimated distance to each satellite is called the pseudo-range. Communication between GPS receivers and satellites happens with radio signals. There are several things to consider with this. The first thing we will talk about is that GPS satellites transmit 2 radio signals that are on different L-band frequencies. L-band is the segment of the radio spectrum ranging in frequency from 1000 to 2000 megahertz. These 2 frequencies are called L1 and L2. The L1 signal carries 2 codes and a navigation data message, and the L2 signal contains only 1 code, which is encrypted to prevent fake GPS signals. There are 2 systems available for positioning service by GPS satellites. These 2 services are the Precise Positioning Service and the Standard Positioning Service. The Precise Positioning Service is only available to be used by military, some government agencies, and authorized civilians. This system uses both L1 and L2 signals. The other service is called the Standard Positioning Service, or SPS. This system is available to civilian users, but only allows the use of 1 code on the L1 signal. Accuracy for the Standard Positioning Service results in errors less than 43 feet horizontally and 72 feet vertically, 95% of the time. Some newer GPS receivers are dual frequency capable, meaning they can use both the L1 and L2 signals. However, these receivers have to use tricks to use the L2 signal. With being able to use both of these signals, the receiver is then allowed to correct for ionospheric effects, which we will talk about later. GPS receivers also need to be able to identify which satellites they are pulling a signal from. Each satellite can be identified by either its Space Vehicle Number, SVN, or Pseudo-Random Noise Code, PRN code. Each satellite has a different PRN code in its signal, making it so that each satellite can be thought of as having its own distinguishable voice pattern. Also, Each satellite transmits information with approximate data for all satellites in the GPS constellation. This allows a GPS receiver to find any and all satellites that are in view once the first signal has been acquired. The last thing we will talk about before getting into GPS accuracy is carrier phase tracking. This method for determining position is considered to be more accurate than pseudoranging and is used in applications where extreme accuracy is needed, such as in surveying. In surveying, you want to make sure that when you are marking a property boundary, you are being as accurate as possible. Being off by 43 feet in this situation could cause an issue down the line between property owners. However, a carrier phase tracking is expensive and requires two special receivers that examine GPS signals very closely to determine changes in waveforms over time. Using this method, you can bring the position estimate down from being within 43 feet to within a few inches or centimeters. What we've covered so far is presented in the first 9 pages of Chapter 2 in your text. Here we've talked about what GPS is, the GPS system, and the 3 components that make up the system: the user, control, and space segments. Further, we talked about what satellite ranging and how it can be used to determine your position on Earth, or maybe your favorite fishing spot. Lastly, we covered some satellite terminology involving discussion about satellite signals and services, as well as some facts about GPS receivers and how they work. The next segment in your book that we will cover is about GPS accuracy, the factors affecting it, the different types, and what you might use them for, as well as what tools you might need in each type.